with you a school-wide project that you could do at your school that incorporates computer science. Let's take a look again about what computer science is. Remember that computer science is the foundation for all computing, and it's defined as the study of computers and how the algorithmic process works to make a computer work, to make it run, and to show all the great things that we love to interact with when we are using technology. I want you to think about computer science in 4 buckets. There's lots of different ways that we can include computer science in our work and in our thoughts when we are teaching our students. There's programming, digital, data, and infrastructure. Today, we're going to focus a little bit on the data component. All things that drive the way in which we interact with computers, marketing, our students, how we buy materials, all drive from this concept of data. Data is used to help us make decisions, and it's at the core of what makes a computer work. It looks at things that are binary, zeros or ones, on, off. It understands algorithms if something is happening then, and that's all data being analyzed. But we're going to look here from a computational thinking lens as well for this particular project. And remember that computational thinking is when you decompose a problem, pattern recognize, abstract, and then create an algorithm. So what is this project that I'm talking about? Well, before we get into that, remember there are a couple of core computer science vocabulary words that are going to be used no matter what project we're doing. And that includes conditionals, which are your if-then statements. If I do this, then. Data, information, often quantities, sometimes characters and symbols, but it all is going to be collection around information. A variable, which is a placeholder. We're going to talk about that in the project. An algorithm, which is a list of steps to finish a task. A loop. This happens when you want to do something over and over again. And I love this because in computer science, we fail a lot. It's how sometimes and always really innovation happens when something fails and you figure out another way to make it work. So this project in particular is a food bank service learning project. Many times in schools, we have opportunities where we are collecting food, collecting jackets, maybe school supplies that we are going to use to give back to our community. So in this particular food bank project, you want to reach out to your local food bank and ask, when are they collecting food? It could be around the holidays, it could be around summertime, in the winter, or it may not be food. It could be school supplies or coats, as I mentioned, or other items that are needed in your community. Now, once you have this idea of which food bank or community partner you're going to work with, here are some of the computer science components that you can add. First, as a school, what we want students to do is bring in items for the collection. Well, what we need to do then is let's just collect some data on those items. So as students come in, what I ask teachers to do, or admin staff or support staff, is to create a chart, one for each classroom. And on that chart, you identify the food items that are needed and non-food items. And when students come in and they bring in their items to donate, you use a simple tally mark to tally what is happening. So if they bring in canned meat or fish or peanut butter or pasta or whatever it is, you simply put a tally mark. And they themselves, the students, can do that. Or you could put a student in charge of this. This ranges from elementary all the way to high school. You could have this activated in your homerooms, in your special times of the day. Sometimes you have periods where students come back together for clubs or whatnot. Or it can be in elementary school, the student's just homeroom teacher. So then they bring in those items, we tally it up, and at the end of each week, we're going to take that information and find out the average, the mean, the mode, etc. You can see an example here of the food donation chart being set outside a teacher's classroom. It would be wonderful if they were set outside the classroom, but you could also place it in there. You can also see here that this is a collaboration of all the food that was donated. If you're going to run the project for more than 1 week, you can have 2 different charts and then compare the 2 weeks together. It's a great way to showcase how you're incorporating math, data collection, and science. If we bring in this so many items, then, and you can begin to see what kind of items are coming in from the students. So you can calculate that five number summary where you have average, mean, mode, min, max. And then you can begin to talk about predictability. What would happen? What do you think is going to happen when you bring in information or items for the next week? A couple other things that you can bring in, of course, is a simple math problem. $1 equals 7 pounds of food, which equals 4 meals. This is a particular statistic from one of the food banks that we partnered with. Well, you can bring in some other items about what's the difference between money currencies. And that could happen in social studies, English, or math, or in science. Here's a couple science ideas to think about as well. Portion size, nutritional value, and the components of a canned item or dried item. Something interesting that we've talked about quite a bit in 7th grade is sugar and how sugar affects the way in which we digest our food. Could be a really cool science. How many of the items bring in so much sugar? And this one, the last one, is social studies. How we get geographical regions, how it's different in every region, what is a donation versus what is purchasing, and how do we build community? These are all things that you could do to elevate the food bank project. And then as a school, you've come together and implemented some concepts around computer science and computational thinking. You can think about how that would even be leveraged to a whole nother level with robots. How could robots help facilitate the actual, once you have all the items, you've got to sort them. And oh my goodness, who wants to do all that sorting? And how could a robot help with that? So many cool things. But today I wanted to showcase a school-wide project that would have a computer science component. And that is based on a food bank service learning where the students are able to apply computer science and computational thinking and also give back to the community. Thanks so much, and check out more about these options on the.consulting.co, or you can send me an email at sharon@the.consulting.co. Thanks so much, and talk to you soon.